Welcome to Chapter 3 of our HDX-DIA educational series. In this chapter, we will explore a crucial decision in HDX-MS experiments: how to acquire MS2 data. The choice between data-dependent acquisition DAA and data-independent acquisition DIA methods can significantly affect data quality, throughput, and the ease of interpreting results. We'll review how DDA preselects peptide precursors for fragmentation, why this approach presents challenges in HDX, including shifts in peptide deuteration and signal overlap, and how DIA overcomes these limitations by fragmenting the entire mass range, making it possible to analyze more complex peptide mixtures with confidence. By the end of this session, you'll understand why DIA is helping advance HDX-MS toward more reliable, large-scale applications.
When we're looking to acquire MS2 data for HDX, we have a choice of two methods. The first method is a data-dependent acquisition, or DDA, and the second method is a data-independent acquisition mode, or DIA. In DDA, we would have to pre-select our precursors or peptides ahead of time and let the mass spec fragment them independently into independent MS2 scans. There are a few problems with this method. The first is that the DDA windows must consider the peptide deuteration. So in HDX, we don't know ahead of time how much a peptide might shift to the right, and so we would need to set the isolation windows to account for all the possible shift of that peptide might encounter after being deuterated. Another problem is that if we have a lot of peptides, it might be difficult to select DDA windows for all of the peptides in our sample, especially if we're running very narrow gradients. And finally, if we do have to use large isolation windows because we have to consider the peptide deuteration, we may still need to deconvolve the MS2 signal, right? Because if we use large isolation windows, then we might run into the problem of having multiple peptides fragmenting together, so we would have to deconvolve that signal anyway. In DIA, we use large isolation windows that are adjacent to each other to fragment the entire mass range. And in each isolation window, there could be multiple peptides that fragment together. And so DIA allows us to sample the whole mass range, unlike DDA, which you would have to limit it to only pre-selected precursors in the spectrum. And because of that, we can now handle more complex data with no limit on the number of peptides, right? Because we fragment everything anyway. And so while some of the isolation windows will contain mixed signal from multiple peptides, the deconvolution problem of the MS2 signal has been somewhat solved in proteomics. So we use some of the techniques to split the fragment signal for individual precursors out of the MS2 scans.
In this chapter, we explored how DIA opens the door to fragmenting the entire mass range for more comprehensive results. Next, we'll take a closer look at strategies for setting up DIA windows, how their placement affects data quality, the potential pitfalls like edging effects, and how overlapping or staggered cycles can help ensure every peptide is captured reliably. Let's continue.